Hey everyone, welcome back to the channel. My name is Michael and I'm going to be talking about more internet computer. So over the past year or so, I've been doing a ton of research into internet computer. Been learning how to build applications with Motoko, and I decided to start recording videos or making YouTube videos, and just to share the knowledge that I learned over time. And really, I want to also, find a community of people who actually care about internet computer, because in my day-to-day life, there's probably zero people who care. So yeah, that's why I'm here. I want to learn, want to share what I'm learning, and hopefully inspire other people to look more into internet computer and start building some amazing projects and just changing the world that we live in. So with that being said, I want to go over a forum post that I found. I thought it was really interesting, right? So let's see. So the title of this post is IC Topology, Target Topology Reached, and it's from Sven with the Definity team. And it reads as such. Last year, the community has voted on an IC target topology with the maximum number of node machines, as well as on an optimization model to validate candidate node machines against this IC target topology. The IC target topology has been reached by December of 2023. See for more information in this forum post, which is linked there. And we're gonna go and check that out in a few. Right, so the IC target topology has been reached as of December 23. This means that the IC network currently does not require any additional node machines in order to reach its decentralization targets. Therefore, Definity will not adopt any proposals for new node machines being added to the IC network. Once the subnets are reaching capacity and more subnets are required to run all applications, the community may decide to increase the target topology again and allow node machines on the network. So in a nutshell, internet computer is made up of subnets and nodes, right? The subnets are collections of nodes that run collectively. The nodes in a subnet run like their own consensus algorithm, form their own blockchain essentially, and are used to host applications that get deployed onto the network. So there's a target topology, meaning there are a set number of subnets that we're aiming for with a set number of nodes in each subnet. And we're gonna, this video will help understand what all of that is. So just a quick overview of a few terms, right? Or, the building blocks of internet computer, which would be nodes and subnets. So first we're gonna talk about nodes. These are high performance hardware that run applications on the IC. They are independently owned and controlled. So you cannot spin up a node on like an AWS cloud instance, for example. If you want to be a node provider, you need to have proof that you actually purchased the nodes. So yeah, you need to purchase the nodes. You need to have proof that you purchased them, proof of identity, who you are. And then the nodes also need to be located in the data center. So I believe you need some evidence of that. Right, so node providers can be individuals, they can be companies. And when they set up these nodes, these are machines that they're running in the real world. So they incur real world costs. So that can include the cost of actually buying the machines, operating the machines, hosting them in a data center and maintaining those nodes. And then in exchange for providing computation and storage to the network, node providers get paid in ICP as a reward. Right, and then next we have subnet. So a subnet, as I mentioned, is a collection of nodes. They run their own instance of the ICP consensus mechanism, essentially creating their own blockchain, like I mentioned. And then there are a few different types of subnets. So we have NNS subnet, which is the largest one, consists of 43 nodes. And we'll see more on this, but the short reason why this has so many nodes is this is the critical infrastructure of the internet computer network. So it is very crucial that it remains operational and is not vulnerable to attacks. So having more nodes makes it more difficult for any set of nodes in the subnet to gain control. Similar for SNS subnet, this subnet is used to host applications deployed to the SNS. Then we have fiduciary, which are used, I think, particularly for things that involve like DeFi. And yeah, we'll get into more of this, but these are a few different subnet types, and along with the number of nodes in each subnet. Okay, so why do we need to have decentralization targets for an internet computer? First, decentralization helps keep the network secure against malicious actors. You know, if there are hackers who gain access to some nodes in a subnet, you don't want them to be able to take the whole subnet down. So having things decentralized makes it harder for malicious actors to gain access to or control over multiple nodes, because they're operated by different places, or they're operated by different people, they're operated in different geographic locations, and so on. So yeah, that is what decentralization is. And then the goal with having decentralization targets is to strike a balance between the node provider rewards, the network performance, and the decentralization of the network. So let's look at this example here. Numbers don't matter, but let's say we have some number of node providers making some amount of money every day for providing computation to the network. And let's say they're providing significantly more compute than is needed for all applications on the network. Increasing the number of node providers has the following effects, right? First, it increases the cost of running the network, because these new node providers that have been added now need to be paid in ICP for running their machines on the network, right? So this increases the cost of the network, and then it also wastes unnecessary resources, because as a node provider, one, you need to go and spend your money to buy the machines, like the node machines. You need to have them you need to pay the money to buy the node machines. You need to set them up in the data center. You need to maintain the nodes. And then like these nodes are taking up electricity. And if they are not being used as efficiently as possible, then this is a huge waste of resources. And the case with this example is that they won't be, because there is more compute being provided than is needed for all the applications on the network. Maybe more applications at some point could come online and use up those additional resources, but there needs to be a balance between the available resources on the network and how much it is actually being used, right? And then the third point is that adding more node providers can negatively impact decentralization if it is not handled correctly. So we'll see more on that in a bit. So how is decentralization of a network measured? We have this metric called the Nakamoto coefficient. This is a very common metric that is used to measure, the decentralization of like different crypto networks or blockchain networks and so on, right? And the higher this number is, the more decentralized the system is. So traditionally, the Nakamoto coefficient represents the smallest number of entities that are required to control 51% of the resources in a system. Whereas in ICP, this number is adjusted, and we'll dive into it more, but roughly the Nakamoto coefficient represents a third of the nodes that need to act maliciously in a subnet in order to cause issues, right? So that's the first metric, Nakamoto coefficient. And then next we have another metric called the subnet limit. So this number is correlated to the Nakamoto coefficient, but is much simpler to think about and reason about. So this one denotes the maximum instances a specific characteristic can appear within a subnet. We'll talk about what characteristics are in a bit. So for example, a subnet limit of 1 on the country characteristic indicates that a single country cannot control more than one node in a given subnet, right? And there are 4 characteristics that Internet Computer uses for measuring decentralization. So first is country, right? This is the country that the nodes are located in. Then we have the node provider characteristic, which describes the entity providing the nodes to the network. So who's the company or individual or whatever. Then data center, where are the nodes where are the nodes actually at? Like what data center are the nodes at? Then data center provider. I'm not quite clear on what this is, but look, like from the research that I've been doing, it seems like the data center provider is analogous to a region in AWS. So like US East 1, US East 2, they have different data centers within that store data and do computation and all that stuff. Right, so these are the 4 characteristics that are used to measure decentralization. So now we're gonna go look at the forum, and we're really gonna get a good understanding of the internet computer topology. All right, so this is the post I read initially, and it links to another forum post, which was like the original pretty much. So this is also from Sven. And this post was on the new node provider proposals topic, I think they're called or referred to it in this forum. So this topic is where new node providers come and say, hey, I want to be a node provider. Here's my information, like pretty much making the announcement and then sharing links to like verification of identity, proof of purchase and so on. That's what this topic is for. So Sven, within this topic, made this post, and it reads as such. I would like to share that with the latest pipeline in Node Machines Live, we have now reached the IC target topology, as can be seen from the graph below and verified using the latest data from the decentralization repo. This is an important milestone, as it means that for all subnets, there are sufficient Gen 2 node machines and Gen 1 node machines that reach the targeted decentralization coefficients, which would be subnet limit of 1 for node provider, data center, and the data center provider characteristics, and a subnet limit 2 or 3 per country. So yeah, and then there's some more links here that we're gonna go through in a bit as well. It also means that adding more new node machines to the IC network will not further improve the decentralization coefficients. So as agreed by the community, the foundation will reject any new node allowance proposals and node reward proposals, except for the existing node onboarding pipeline. So these are machines that have been ordered before December 1st with evidence on the wiki page, and node machines that have been added to the decentralization with output of optimization tooling shared. All right, whatever. So yeah, and then the final point here, note that IC being a decentralized network, the community may still decide to adopt specific proposals and add node machines. Right, and then here we have this graph that Sven mentioned in that post, right? And we can see, hopefully this is large enough. Let's just make it a little bit larger. So we can see the node allocations per subnet by node provider. So we have a bunch of different node providers here. You see a bunch of companies and even some individuals, right? And they're represented by a unique color. And the color, right? So the color is the node provider, and then each bar here is a subnet. So this is one subnet, a separate subnet, so on. These down here are all application subnets, which, yeah, we'll talk more about that, right? And what else? Yeah, and then this is the number of nodes, right? This axis represents the number of nodes. So like in this subnet, there are like 20 something, maybe like 28 nodes. This one has 34, and you get it. All right, so let's move on to the next post. Okay, I'm zoomed in way too much. Way too much zooming, and I lost the post that I initially was looking at. Let's just go back and click it. All right, so in a nutshell, what this is saying is there are some targets that were set last year in November, and those targets were met pretty much. So we're not accepting any new node providers. The community can decide to, but Dfinity itself will not be accepting, and will, I think, actively be rejecting them. So let's now look at Okay, yeah, we're gonna look at these forum posts, and these really where the meat of this whole conversation is. So TLDR, the internet computer operates on physical node machines, commonly referred to as nodes. To achieve robust decentralization, these nodes are operated by different providers in multiple data centers by different data center providers, and in many countries. Yeah, we gotta figure out what data center providers are. Maybe I'll make a post on the forum asking. But whatever, let's continue. Decentralization is well achieved in data center and data center provider characteristics. While node provider decentralization is nearing optimal, some providers operate too many nodes relative to available subnets. There is an over-representation of nodes in the US and Switzerland when considering the country characteristic. So these are the findings in the current state as of this post, which was made in September 2023. So this post offers a preliminary assessment of node decentralization, focusing on individual node characteristics. In subsequent posts, we'll explore more metrics and provide some targets or whatever. Right, so we have the problem statement here. In order to strike the right balance between network size and cost and degree of decentralization, the IC needs to tackle two aspects. First is establishing a target topology. So this involves defining the number of subnets and their respective sizes, aligning with anticipated future demand. And then the second aspect is optimization. So given a target topology, you want to optimize between node rewards and decentralization. So let's jump down to this table here. This is just a table showing the nodes by node provider. They're grouped. Each row is a single node provider. So down here at the bottom, we see Definity. They have a total of 95 nodes. Then we have some aggregators like Palnu Logistics, which is right above Definity. So I guess this is, what is an aggregator? Nodes that are maintained by specific service providers and not directly by the node providers. So yeah, so there are some node providers, there are some aggregators that are also represented here as node providers. Right, and then if we scroll down, we see some more useful information. All of this is very useful, but I'm not going to read everything in this video because I think you guys might die of boredom. And even I will get tired of hearing myself talk as well. Yeah, so we have some information on subnets. Yeah, and then this matrix here shows the current allocations for subnets. So there are 36 subnets, and each cross in here is a slot for a node in the subnet. All right. So yeah, these are all application subnets because they only have 13 nodes. This one with 40 or probably over 40 is the NNS node. We got the SNS. The NNS subnet, SNS subnets, and then these are probably like the fiduciary subnets. Right. So, right, like I said, the crosses are the spots for the nodes that are allocated in the subnet. So now we get into the initial assessment of the node decentralization, right, in which we're gonna evaluate these four characteristics: node provider, data center provider, and country. For optimal decentralization, each subnet would only have unique representations of each characteristic. For example, within any given subnet, each node provider should be represented only once. Right? So we're gonna visualize this in the matrix. In the matrix, baby. Red pill, blue pill. Red fish, blue fish. One fish, two fish. I'm hungry, gotta chew fish. I do this. It's true this. You know? I had to hit y'all with that real quick, but I was inspired. So to visualize this, consider a matrix. We have termed the node topology matrix, where the tiles in the rows represent nodes sharing certain characteristic. Crosses in columns signify the required slots within a subnet, and a cross overlaying a tile indicates that a node from that row's characteristic is mapped to the subnet denoted by the column. right? So each row, let's open this up. Each row is a single node provider. They're represented one time in each subnet. With this setup, we can see there's some X's at the top here that are not filled, which means using this subnet limit of 1 for a node provider, we currently don't have enough node providers to fill up the NNS subnet. Whereas some of these other subnets where all of the crosses are covered or are, filled by some color, there are enough for those subnets to be decentralized with a subnet limit of 1 for the node provider characteristic. All right. So let's see what they say down here. From the matrix, we can infer that achieving near optimal decentralization is plausible. Notably, only 9 subnet slots visible as crosses, not overlaying tiles, remain vacant in the 2 most substantial subnets to the left. When mandating a unique node provider representation in each subnet, I read that weird, but hopefully you guys got that. Additionally, it becomes clear that several node providers have a disproportionately high number of nodes compared to the total subnets available. All right, so that would be these at the bottom. There are 36 subnets where some node providers have more than 36 nodes set up. So Definity with 95. So I think the problem here is that when these go to be used to fill these other slots in the subnet, then it becomes a situation where whatever provider's nodes are used to fill those slots now are in breach of that subnet limit, and there's a negative impact on decentralization of the subnet. Right, and then if we look at for data centers, we can see there are more than enough data centers for the subnet there are more than enough data centers for each one to be represented uniquely in the subnet in the subnets. However, they don't all have enough nodes to be represented in every single subnet, which is okay though, because you can then even though, let's open this up again, even though these at the end here don't have any nodes in them from these providers, you can take some nodes from these other providers, or from these other data centers, I should say, and stick them down here, and these subnets can still be decentralized with a subnet limit of 1 for the data center. So data center characteristic is looking really good for the network. So yeah, like I said here, it's worth pointing out crosses in the bottom right, which do not overlay tiles, do not present a decentralization concern. These available slots can readily be populated using unassigned nodes, which are the tiles without the crosses, without compromising the decentralization objective. And similar deal for the data center provider characteristic. Right, now if we go and look at country, this is where it's interesting. And if you remember from the initial forum post that highlighted the target that was actually reached, there's a subnet limit of 2 or 3 for the country characteristics, depending on which subnet you're looking at. So here's what the topology looked like in September, right, by country. We see US has 448 nodes, China has 175, whatever, right? But there are nowhere near, there are only 15 unique countries operating nodes on the network, but we need 40, 40 plus to have a fully unique set of countries in a single subnet, like in the NNS subnet. So how do we solve for this? We're going to see. Right, it says a stark contrast is evident when compared to previous characteristics. Currently, nodes are only placed across 15 different countries. Given this limitation, it is infeasible to fill the large subnets on the left while insisting each country is represented only once within a subnet. This challenge is highlighted by the 50 plus crosses in the top left that do not overlay tiles. See? Even among some of the application subnets with 13 nodes, there's a scarcity of diverse nodes because some of these countries aren't even operating enough nodes to cover all of the subnets. All right, so to address this, we could moderate our decentralization standards, proposing that a specific country should at most be represented twice instead of once within a subnet. So this matrix shows what that would look like. And you see we get a little closer to filling all of these crosses here. So yeah, we have a subnet limit of 2. So we can see each country has two rows allocated, and things are looking much better. All right, but still not quite there. So let's see what this says here. Software target appears more attainable. Only 13 subnet slots in the top left remain unoccupied under this criterion. Crosses in the middle that do not overlay tiles do not present a decentralization concern. They can be populated using unassigned nodes from the upper rows without compromising the decentralization objective. Furthermore, it is clear that from the picture that even under this weaker decentralization target, we have far too many nodes in the US and Switzerland. And then there's some preliminary conclusion, which pretty much mirrors what we saw in the TLDR. All right, so now we're gonna jump straight into the second post, or the second part of this blog series, which I have open in the tab here. And let's scroll to the top. So this one, where the first post was giving some background and giving an overview of the topology at the time that post was created. This post comes in, it does a recap, and then it provides some targets for the actual, for us moving forward. It provides some targets for us moving forward. Sorry, I got brain fart trying to read through this. So let's see. This is a ton of useful information in here. Some of it I covered, but I would recommend reading this as well for yourself. I'll add links to all of the resources in the description. So let's scroll down. There are some more tables here. So here's the suggested target subnet structure. All right, and this is the chart that we looked at earlier as well. You can see the subnets with the number of subnets, one of all of these, and then 31 application subnets. And then, we see the number of nodes, so on. All right, and then the actual decentralization targets that we have are here. Decentralization target 1, a subnet limit of 3 for all characteristics. So that means a node provider can be represented at most 3 times in a single subnet. A data center, same for a data center, same for data center provider, same for a country. All right. Decentralization target 2, subnet limit of 2 for all characteristics. Target 3, subnet limit of 2 for the country characteristic and 1 for other characteristics. And then the final target is a stringent subnet limit of 1 for all characteristics. All right. And then there are some tables here. So these just show so this is node allocations per subnet by country. So this shows what it would look like if countries were represented more than once within the subnet, pretty much. And then, they go through this and just put these targets into a graph, into a chart for us to see. Right, so this is how the decentralization targets are formed. I hope this was clear, and definitely leave me any questions or feedback that you have about this stuff, right? But this is, in a nutshell, how the decentralization targets were reached, or like how we even determined what targets to use. And then now I'm going to show where the targets were actually voted on. Let's see. So we have these proposals. Let's open these up. This first proposal here this one is just suggesting that we establish a target topology, right? That's the goal of this one. So it highlights a lot of the information in those forum posts and probably references them. I don't see any links. Yeah, okay, so yeah, this one links to the post, right? So just saying here's the idea and here's why we need to set a target topology for the network. So that one was met with a resounding yes. Then this proposal, also a motion proposal, just sets what the target topology is. And once voted on, that is what Definity is moving forward with, and the community should be as well. So once this is reached, we should be rejecting, proposals for new node providers unless they met the requirements that we mentioned earlier. So being like if they started the process in December before the target was met, I think they'll still be able to become node providers, right? And yeah, we see the table that we've been seeing with 2 additional columns indicating the subnet limits. So these are the proposals that were actually submitted on the network and accepted by the community. And yeah, I think that's pretty much it. That's everything I want to cover, right? So we went over we got a little overview of the architecture of the network, what subnets and nodes are, what is decentralization, why is it important, and then try to get an understanding of what the targets, like what is the structure of the decentralization target and how do we reach those targets that we had set, right? Because this was a huge milestone, right? Target topology reached. There's a huge milestone at least from what I'm understanding, right? Because I didn't realize I just didn't realize this is how the network was operating. I didn't realize that. I thought just like whoever wanted to be a node provider can come on and be a node provider, and that's kind of just it. But now that I've done this research, I have a better understanding that we can't just allow anyone to become a node provider at any point in time anywhere in the world, because that has impacts on the decentralization. All right, so I hope that point came across clearly in this video, and let me know if it didn't, and I'll work to make things more clear and easy to follow in my following videos. But yeah, I think this is amazing, right? Because we have targets that are limiting the network and placing reasonable limits, and not over allocating resources, right? Because I think that is one of the huge problems in tech. We have a enormous misallocation of resources. So that can be with money, with human, with human labor. So hiring too many engineers to work on a project that just doesn't need that many engineers, or if a company is having like maybe too much money invested, they kind of just sometimes will go and blow the money on things that they didn't need to scale. And yeah, the fact that Internet Computer and Definity are focused on making sure that we are not wasting resources is amazing to me. And the fact that the community can come in and have input, like we get insight into these decisions, and we also have control over the actual decisions and if they are executed or not. So I think that is amazing. And this is why I'm a huge fan of Internet Computer, huge supporter. I spend a ton of my time developing and learning how to build applications. And now I'm making video content to share things that I'm learning. So I'm all in on Internet Computer. I think if you're a developer, it is very worth your time to, do some research on Internet Computer, understand if this is something that interests you, because I think it is the future of software development. And really there's potential for, a really amazing world to come out of Internet Computer being adopted heavily, right? And I'll get into, I think I'm going to do a video highlighting just what is possible in the future. Like what are the moonshot, like with the moonshot vision, at least the one that I have for internet computer, and what kind of world do we have? So stay tuned for that. But enough of me rambling on here. If you enjoy the video, like, subscribe, all that stuff. And yeah, let me know what you think. I hope this was interesting. Peace.